Those battery cells have truly shown their value when it comes to energy storage and real-world capability. And honestly, we're just at the starting point of what they can do. Until recently, it made sense to question electric vehicles. Can they really go the distance? Will they charge fast enough? Do their batteries last long? Are they affordable for the average person? As of now, the battery remains the biggest source of doubt and the main challenge in making electric vehicles more common. Not every electric vehicle today can travel over 300 miles. Fast charging can still take around 30 minutes, and many people are hesitant because of worries about battery degradation, with some batteries losing more than 25% capacity in only a few years. To add to this, most electric vehicles in the United States are still working to prove themselves, while electric vehicle makers in China are moving ahead quickly. But Tesla is working on a new type of battery that's advancing faster than almost any other tech we have seen so far. Each year, driving range improves by 35%. Charging time drops to only about 5.9 minutes. Manufacturing costs fall to $97 per kilowatt-hour. And due to better materials, battery lifespan is now heading toward 30 years. Automakers like Ford, General Motors, and Hyundai are watching closely and investing tens of billions of dollars into this next big step. So, what kind of groundbreaking battery is Tesla creating? And when will we see these powerful batteries in real cars? Welcome to AMP Drive, your destination for the latest updates in Tesla innovation, electric vehicles, and future tech. If you enjoy learning about these exciting breakthroughs, make sure you hit the subscribe button and turn on notifications. We truly appreciate your support. Let's keep going. Now, just because Tesla is pushing the limits of their own battery technology does not mean they're ignoring other developments. Yes, other big names like Mercedes-Benz are investing heavily in solid-state batteries. Chery is also entering the competition, and many companies are treating this technology as a golden ticket to the electric future. From the outside, it might look like Tesla is not doing much in this area. But that's exactly the kind of move that keeps them one step ahead. While the rest of the market makes a lot of noise about solid-state batteries, Tesla has been quietly improving its own battery systems in plain sight. The fact is, Tesla batteries are improving year after year. They charge quicker, they perform better, and most importantly, they are becoming more affordable. As Tesla's Vice President of Vehicle Engineering Lars Morave mentioned, battery improvements at Tesla have always been steady, around 3% better energy density every year. So here's the thing, if battery energy density keeps going up, charging becomes faster, and prices keep dropping, then what's left to complain about? Just look at Tesla's battery prices. Back in 2013, Tesla was paying over $800 for each kilowatt-hour. Today, that figure has dropped to about $110. And by the year 2026, the target is just $97. That is less than the cost of lithium iron phosphate batteries, which have always been considered the cheapest battery chemistry. A lot of people still argue that electric vehicles are too pricey, too slow to charge, or have poor range. But these arguments are quickly falling apart. Let's take range as an example. It just keeps getting better. Remember the Tesla Model Y? Earlier this year, the all-wheel drive version had a range of about 530 kilometers. Tesla made an update and suddenly it went to 550 kilometers. Fast forward a few months and now it can reach 600 kilometers. No big advertising campaign, no huge press event, Tesla just quietly made it better. And the rear-wheel drive version? That one has already had a 600-kilometer range for a while, using a smaller and more budget-friendly battery pack. So, what's your guess for the future battery cost of the Tesla Model Y? Share your ideas in the comments. We'll respond to the most interesting ones. The trend is becoming clear. Electric cars are becoming more capable and less costly every single year. And the biggest reason behind this change? Battery prices are falling. Energy density is going up. Charging is getting quicker. And Tesla is leading this charge, pun totally intended. Now, do we actually need solid-state batteries? Sure, they sound amazing. They promise faster charging, better energy density, and lighter weight. But let's be honest, lithium-ion and lithium iron phosphate batteries are already doing an excellent job for most drivers. They are working right now. They are being produced in large numbers. And they are becoming cheaper every day. Battery technology is central to everything Tesla does. Every Tesla product runs on batteries. Lithium iron phosphate batteries are now the lowest cost option worldwide. In the near future, sodium batteries might even replace lithium iron phosphate batteries in energy storage. Even though sodium has lower energy density, it does come with benefits. One of them is cost. Sodium is much cheaper. So, this shift is coming. The lower-priced electric vehicle segment will most likely be powered by sodium-ion batteries very soon. And these vehicles will be even more affordable than traditional gasoline cars. Tesla deserves credit for recognizing these changes early. They were the first company to use lithium iron phosphate batteries in cars at scale. Not just in a few models, nearly 70% of all Teslas have used lithium iron phosphate batteries long before other carmakers caught on. And when Tesla spoke about the future of batteries, they might have been right all along. Why? Because while many still think of batteries as something fixed and unchanging, there's a new trend gaining ground. In just the last 6 months, we have seen charging speeds double, or even quadruple, from 250 kilowatts to 300 kilowatts. That's not the upper limit anymore. Now we are talking about 500, 600, even 1000 kilowatts of ultra-fast charging. And the really surprising part? These charging speeds are happening on the same old batteries. Same structure, same materials, same production methods. So what changed? The software. That's right. Car makers finally realized that their existing batteries could handle extremely high-speed charging. With a few software updates, they unlocked faster charging without hurting the battery. And this isn't just about charging. Everything from range to heat control is being improved year by year with software updates. So if you think battery progress only happens when hardware changes, you're missing the bigger picture. Software, cooling systems, and current input levels, all these things are quietly changing the game. And the most exciting part? Performance is going up while prices keep falling. That's almost unheard of in any industry. As production increases, costs come down, and energy storage gets even better. It sounds unbelievable, but that is exactly the world we're moving into. And Tesla seems to have known it all along. When Tesla scaled up production of its 4,680 battery cells at facilities like Giga Austin and Giga Berlin, they did not just make more batteries. They reduced production costs significantly. Even better, energy density actually went up. At Tesla's Battery Day event back in 2020, the company unveiled not just a new battery cell but a whole new way of thinking. The 4680 battery cell, much larger and without tabs, promised to cut the price per kilowatt hour by as much as 56% compared to the 2,170 cells. That is a huge difference. And here's how they did it: 14% came from making the cell bigger. 18% came from better production methods. 5% came from adding silicon to the anode. 12% came from changes to the cathode. And the last 7% came from putting the battery cells directly into the car's frame, removing the need for extra casing. When you combine all that, the 4680 battery is not just a product, it is a financial tool that powers Tesla's electric vehicle plans. And it is not only about money. This design cuts down resistance, allows more current, improves cooling, and lets the battery charge faster. All while staying cooler and lasting longer. To compare, the original Tesla Model S in 2012 could drive 265 miles on a full charge. Now, the top version goes over 415 miles. That is 150 miles more, all thanks to better batteries, not bigger motors or larger fuel tanks. Lars Morave has said that Tesla is switching many of its battery lines to a common block design that they can update every few years. Tesla is also moving toward new battery cells from CATL and LG, while still producing 4,680 cells at Giga, Nevada and Giga, Texas. They even make their own high-capacity 4,680 batteries in-house. So, when will Tesla use these affordable batteries in their electric vehicles? A Chinese company has already said that its electric car next year will reach over 1,000 kilometers with solid-state batteries. What is really interesting is that, for once, they shared the full technical details, layout, materials, and specifications. That almost never happens. They said the battery uses a high nickel cathode, silicon carbon anode, and high conductivity solid-state electrolyte. Combined with 1,200-volt architecture and 12C fast charging, it could reach 400 watt-hours per kilogram. That means the car might drive over 1,000 kilometers per charge. It could charge at 1,200 kilowatts and run a motor at 30,000 revolutions per minute. That is futuristic. Still, while Chinese companies aim for bold leaps with solid-state, Tesla is taking a smarter, steady path, improving lithium batteries in ways that are scalable and efficient. At a July 2025 event, Lars Morave confirmed Tesla is still improving both lithium iron phosphate and nickel manganese cobalt battery lines. These batteries are expected to get 3% better each year through better chemistry and design. Tesla also started building a lithium iron phosphate battery factory in Nevada. This will supply cheaper batteries for the Model 3 and Model Y vehicles made in the United States. It also opens the door for the $25,000 car that Elon Musk hinted at. Reports now show production costs for lithium iron phosphate batteries are falling below $100 per kilowatt-hour for the first time ever. That does not mean Tesla is ignoring solid state. They are still researching it, along with supercapacitors. But unless solid-state batteries prove they can be mass-produced and last long, lithium batteries will remain Tesla's top choice. Panasonic, Tesla's key battery partner, also said solid-state batteries are more of a niche solution right now. That's very different from the big promises we keep hearing from China. Some might ask, is Tesla falling behind? Not at all. Remember this. Tesla is still the global leader in real battery tech being used in actual vehicles. They have not made a car with 1,000 kilometers of range yet, but the Model S Plaid already gives over 600 kilometers. The Cybertruck is powered by 4680 cells, which outperform the 2170 cells. With every new battery version, Tesla boosts energy storage and lowers costs. We are not saying solid state will never happen. In 5 to 7 years, we might see cars that charge in 10 minutes and go 1,000 kilometers. But today, only one company has the batteries to power millions of electric vehicles. That company is Tesla. The future is electric, and Tesla is the one building it now, step by step. Amp Drive will keep bringing you the latest. Subscribe so you never miss a breakthrough.